In a region where electric field intensity is 5 Newton per coulomb, then 50 electric lines of force passing per square meter एरिया दिया है, मतलब ये इनडायरेक्टली फ्लक्स दिया है. द नंबर ऑफ इलेक्ट्रिक फील्ड लाइंस क्रॉसिंग पर स्क्वायर मीटर वेर इलेक्ट्रिक फील्ड इंटेंसिटी इज 20 न्यूटन पर कूलम. तो इसके लिए कितना इलेक्ट्रिक लाइंस पास होगा ये निकालना है. 5 न्यूटन पर कूलम के लिए 50 था, तो 20 के लिए कितना. अब जितना इलेक्ट्रिक लाइंस फोर्स ज़्यादा पास करेगा उतना इलेक्ट्रिक फील्ड इंटेंसिटी बढ़ेगी, तो डायरेक्टली प्रोपोर्शनल रहेगा. तो इसे हम यक्स मानेंगे. तो कर लो x/50 बराबर 20/5. ये कितना आएगा, ये 450 × 4. तो आंसर कितना मिलेगा, 200. देखो, इफ सिग्मा इज सरफेस चार्ज डेंसिटी ऑफ चार्ज for a charged sphere of radius r kept in medium of dielectric constant k, then electric intensity at a distance r from the center, r is greater than r, मतलब ये आउटसाइड पॉइंट है. तो आप आउटसाइड पॉइंट का इंटेंसिटी का फार्मूला पता है, 1/4πε0 Q/r². अब Q को सिग्मा के फॉर्म में रखेंगे. देखो यहाँ पे रखा है सिग्मा इक्वल टू Q/4πr², तो Q बराबर सिग्मा 4πr². पुट करो 1/4πε0 सिग्मा 4πr²/r². 4π get cancel. Then electric field intensity equal to sigma r²/ε0 r². But medium with dielectric constant k, right, k with ε0. Then answer is sigma r²/ε0 k r². Electric field intensity at outside point. A charge 12 microcoulomb is kept inside the closed surface. What is the electric flux through the portion of surface which subtend a solid angle pi at the point where charge is situated? When for any closed surface at the position of charge, when solid angle is 4 pi, then flux passing through that closed surface is Q/ε0. But for angle pi, what amount of flux passing through that portion, closed portion? It considered as phi dash. Solid angle is phi. Then take the ratio up to phi dash by phi equal to pi by 4 pi. Then we get 1/4. Therefore phi dash equal to phi by 4. But phi is nothing but original flux Q/ε0. We get Q/4ε0. Put the value of Q is 12 microcoulomb. 12 into -6/4ε0. We get answer 3 into 10 to the power -6/ε0. Unit of flux is voltmeter. Flux is E into A. Unit of E is volt per meter. Area is meter square. Therefore voltmeter. Another unit is Newton per coulomb. E का unit, A का meter square, Newton meter square per. Electric field in the region is directed radially outward with a magnitude of E equal to AR0. What is the charge contained in the sphere of radius R0 centered at origin? Now electric field in a region is directed radially outward. Therefore charge must be positive. We have to first consider a sphere of radius R0. Then charge contained at the center is considered as plus Q. Right? Then electric field in a region is directed radially outward. Electric field is represented by E equal to AR0. First equation of flux phi equal to closed integration of E dot ds. Second equation is phi equal to Q enclosed by ε0. Therefore integration of E ds is equal to Q enclosed by epsilon 0. But on the surface of sphere, E is constant, or E is represented by AR0. Sorry, E is represented by AR0. Therefore, integration of AR0 equal to AR0 into ds equal to Q enclosed is Q by epsilon 0. A, then R0 is constant. Integration of ds equal to Q by epsilon 0. Integration of ds is nothing but area of sphere, A R0 into 4 pi R0 square equal to Q by epsilon 0. Therefore, charge enclosed Q is equal to 4 pi this epsilon 0 E0, sorry, 4 pi epsilon 0 A and R0 square R0 cube. Therefore, charge enclosed inside the sphere is a charge Q is placed at the center of cube of side A. Then, what electric flux diverging from each face of the cube? अब डाइवर्जिंग मतलब बाहर जा रहा है तो पॉजिटिव चार्ज लेना पड़ेगा अंदर, ठीक है. क्यू दिया है उन्होंने, क्यू माइक्रोकूलम. फ्लक्स इज इक्वल टू क्यू इनक्लोज बाय एप्सिलॉन नॉट. बट व्हाट फ्लक्स थ्रू ईच फेस ऑफ द क्यूब? दिस इज टोटल फ्लक्स. फ्लक्स थ्रू ईच फेस is total flux by 6, therefore Q by 6 epsilon 0. But value of Q is 1 Q microcoulomb, convert into microcoulomb to coulomb, minus 6 coulomb by 6 epsilon naught. Answer is C. The electric field in the region is given by vector E equal to AI cap plus BJ cap, where A and B are constant. The net electric flux passing through the square of area of side L parallel to YZ plane. Area in YZ plane. Therefore, area vector is along x axis. Therefore, area is represented by A, magnitude of A I cap. Therefore, flux, net electric flux is product of E dot A, right? E is represented by AI plus BJ, and then area is magnitude of area A and I cap. Area in YZ plane, therefore normal is along x axis, multiply A by I cap. Product magnitude of area, sides are L, then magnitude of area is L square I cap. The dot product, in dot product only I dot I, J dot J, K dot K 1, otherwise 0. Therefore, product is A L square I dot I dot I 1, A L square. J dot I is 0. Therefore, this product with B not considered. Infinite line charge produces the field 9 into 10 to the power 4 at a distance of 2 cm. What is the linear charge density? An infinite line charge is represented by this wire is plus charge. Then what is the electric intensity at a distance 2 cm? Formula is E equal to lambda by 2 pi epsilon 0 r. Multiply and divided by 2. 2 lambda by 4 pi epsilon 0 r. Then we get E equal to 1 by 4 pi epsilon naught is 9 into 10 to the power 9. Therefore, 2 into lambda into 9 into 10 to the power 9 by r. For calculating lambda, ER by 2 E lambda equal to ER by 2 into 9 into 10 to the power 9. Put the value of E, 9 into 10 to the power 4. R is a 2 centimeter, 2 into minus 2 meter. Then 2 into 9 into 10 to the power 9. Now, 2 get cancel, 9 get cancel. Therefore, lambda equal to 10 to the power 4 minus 2 and denominator 9. Then 10 to the power 4 minus 2 minus 9. 10 to the power 4 minus 11. We get 10 to the power minus 7. Unit is coulomb per meter. A point charge produces the electric flux of minus 1 into 10 to the power 3 Newton meter square per coulomb to pass through the spherical Gaussian surface of radius 10 centimeter. What is the value of point charge? We know that the flux does not depend upon shape of the enclosed surface. It only depends on charge enclosed. Flux is nothing but Q enclosed by epsilon naught. Now flux is given, we have to calculate charge enclosed. Charge enclosed is equal to epsilon naught into flux. Q enclosed epsilon naught. Now flux is negative, therefore charge must be negative. Epsilon naught 8.85 into minus 12, and then phi is a minus 1 into 10 to the power 3. Therefore charge enclosed is minus 8.85 into 10 to the power minus 12 plus 3 is minus 9 coulomb. The inward and outward electric flux from a closed surface are respectively 8 into 10 to the power 3 and 4 into 10 to the power 3 units. Then the net charge enclosed. We know that the inward flux is always negative. Inward flux is negative, right? And outward flux is positive. Then total flux is equal to Q enclosed by epsilon naught. Therefore Q equal to epsilon naught phi total. But Q equal to epsilon naught phi total is phi inward plus phi outward. But flux is scalar quantity, take the sign. Then Q equal to epsilon naught. Inward flux is minus, take negative sign, 8 into 10 to the power 3. Outward flux is 4 into 10 to the power 3. Then inward flux is more, therefore net charge must be negative. Epsilon naught minus 4 into 10 to the power 3. Therefore Q equal to minus 4 into 10 to the power 3 epsilon naught. The magnitude of average electric field normally present in the Earth atmosphere just above the surface of Earth is about 150 Newton per coulomb directed downward. What is the surface charge density of Earth? Assume that Earth is conductor having uniform surface charge density. For any conductor, electric field just outside, it does not depend on distance. Its equation is sigma by epsilon naught. Therefore sigma equal to epsilon naught into E. Therefore epsilon naught is 8.85 into minus 12 and E is 150. Then 8.85 into this 1.5 and taken as minus 10. 8.85 into 1.5 is approximate equal to 13.3 into minus 10. Therefore answer is 1.33 into minus 9 coulomb per meter square. A positively charged infinite long cylinder has a radius 0.1 meter. Surface charge density 8.85 into minus 12 coulomb per meter square. What is intensity of electric field at a point on the surface of cylinder? We know that the formula for electric intensity outside point is sigma capital R by epsilon 0 R. This formula for outside point electric field. But for surface R equal to R or small r equal to capital R. Therefore E for surface, this cancel, we get sigma by epsilon naught. Then put the value of sigma 8.85 into minus 12. Epsilon naught is also 8.85 into minus 12. Both are cancelled. We get the equation 1. We get answer is 1 volt per meter. For infinite long metal cylinder of radius 3 mm, K is 6.28, charge density 4 microcoulomb per meter square. What is the electric intensity at a distance 1.5 meter from the axis? For electric intensity for outside point is sigma r by epsilon 0 small r. But for medium with epsilon naught, we take the K as a dielectric constant. Then value of K is 6.25. K is 6.2. Sorry, K is 6.28. K is equal to 2 pi. 6.28 is approximately equal to 2 pi. Therefore, E equal to, put K as a 2 pi, sigma r by 2 pi epsilon naught r. Right? Now multiply and divided by 2 sigma r by 4 pi epsilon 0 r. Then 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9. Then into 2, sigma is equal to 4 microcoulomb minus 6. Radius is 3 mm. 3 into 10 to the power minus 3 meter. Then in denominator only r. R is a distance 1.5 meter. Then E equal to this 1.5 and 3, we get 2. Therefore 2 to 4, 4 16, 9 into 16 into 10 to the power 9, minus 6 minus 3 also minus 9, plus 9 minus 9 cancel. 9 into 16 is nothing but 144 Newton per coulomb. The electric field intensity at a point near and outside the surface of charged conductor. Surface of charged conductor is E1. So electric intensity just outside the conductor is sigma by epsilon 0. Is given as E1. The electric field intensity due to uniformly charged infinite thin plate. For thin plate, we know that E equal to sigma by 2 epsilon naught. It represented by E2. Then relation between E1 and E2. For thin plate, 2 in denominator, and for conducting not 2. Therefore, conducting is double. E1 is twice that of E2. Surface charge density of a charge on a sphere of radius r in terms of electric intensity E at a distance r in free space. Now r is greater than r. Electric intensity for outside point is 1 by 4 pi epsilon 0 due to charged sphere is q by r square. Then for calculating the surface charge density, put q equal to sigma into 4 pi r square by r square, because sigma is q by 4 pi r square. Now 4 pi get cancel. We get electric intensity E out as E. Then sigma r square by 4 epsilon 0 r square. Then sigma is equal to 4 is cancelled. Therefore sigma is equal to epsilon 0 E small r square by capital R square. Therefore answer is epsilon naught E r by r whole square. The Earth's surface is treated as a conducting surface with some charge. What should be the surface charge density of charge so that protons remain suspended in space near the Earth's surface? Suppose this is the Earth's surface and proton is remains suspended just about it. This is proton plus q. Electric field intensity of Earth is upward and weight of proton mg is downward. Then upward force is equal to downward force. Then proton remains suspended. Upward force is nothing but electrostatic force QE, and downward force is weight mg. But just outside the any conducting surface, electric intensity is sigma by epsilon naught, therefore mg. Therefore sigma equal to mg epsilon naught by q. Put q equal to E, then we get sigma equal to epsilon naught mg by E. Flux of the field E is equal to 3I cap plus 24J cap plus 6K cap through the portion of area. Magnitude of area is 5 meter square. Plane, the normal to which area, normal to the area is represented by n cap. N vector is equal to 2I cap plus 4J cap plus 6K cap. Then flux, formula for flux is phi equal to E dot area vector. Now E vector, area vector is n, unit vector n, and magnitude of area A. But unit vector n is vector n by magnitude of vector n, right? Any unit vector is represented by vector by its magnitude. Therefore put vector E, then vector n cap by magnitude of n cap into area vector E. Put the value of E is a 3I cap plus 24J cap plus 6K cap. Then n is 2I cap plus 4J cap plus 6K cap. Then magnitude of n is 2 square, 4 square, 6 square, and magnitude of area is 5. Then take I dot I, j dot j, k dot k is equal to 1, otherwise 0. Therefore 3 into 2 is a 6, 96, 36 by in under root 4 plus 16 plus 36 into 5. Then 20 plus 36, denominator is 56, and in numerator addition of this 5 over 1, 690. Therefore answer is 690 by 56 under root 56 unit. A charge capital Q is uniformly distributed on a ring, this ring of radius r. A sphere of equal radius r, another surface is sphere, constructed with its center at the periphery of ring. O dash is the center of sphere, and this region of ring, yellow color region of ring, enclosed inside the sphere. Charge is uniformly distributed throughout the ring. Total charge is capital Q. Then what amount of charge is enclosed by sphere? Because flux is nothing but charge enclosed inside the body divided by epsilon naught. Now from the geometry of figure, both ring and sphere has same radius. Therefore O dash is a radius. Then again from the center O dash to A is also R. Then again OA is also R. Therefore this triangle is known as equilateral triangle. Similarly, in below triangle also O dash equal OB also R and O dash B also R. Therefore, this also equilateral triangle. These two are equilateral triangles. O dash and O dash both are equilateral triangle. Therefore, angle AOO dash is a 60 degree and angle BOO dash is also 60 degree. Therefore, total angle AOB is 120 degree. Because at the center of ring, total angle is 360, but this angle is 120. Therefore, 1/3 part in front of 120 angle, this part AO dash B is 1/3 part of total ring. Therefore, AO dash B is enclosed charge enclosed in a sphere, and this is 1/3 of total circumference of ring. Therefore, charge on AO dash B is Q by 3, because it is a 1/3 part of circumference of ring. Therefore, charge enclosed inside the sphere or inside the Gaussian sphere is Q by 3. We know that flux passing through the sphere is nothing but Q enclosed by epsilon naught. Now Q enclosed is Q by 3 because total charge is Q by 3 by epsilon 0. Therefore, flux passing through the sphere is Q by 3 epsilon naught. Next problem. The electric field in a region is given by E vector E equal to E0 x I cap by B. X is a represented distance and I cap is represented distance on x axis and B is also distance. Find the charge contained inside the cubical volume bounded by surface x equal to 0, x equal to A, y equal to 0, y equal to A, z equal to 0, z equal to A. Now take E0 equal to 5 into 10 to the power 3, A equal to 1 centimeter and B equal to 2 centimeter. Now, what amount of charge contained inside the cubical volume? Direction of electric field is along x axis E and it represented by E0 x I cap B. Now, this electric field is only along x axis. Then, for calculating charge enclosed inside the cube, we have to first calculate what amount of flux passing through this Gaussian surface or Gaussian cube. Now, this side represents x equal to A, this represents y equal to A, this represents z equal to A, and at origin x, y, z 3 are 0, 0, 0. Therefore, left side is at origin, right side is at x equal to A, y equal to A, z equal to A. Now, direction of electric field only along x axis. यहाँ पे फ्लक्स पास होने वाला है दो ही फेस में, एक लेफ्ट एंड राइट फेस में पास होने वाला है फ्लक्स. टॉप में, बॉटम में, फ्रंट में और बैक में फ्लक्स पास नहीं होगा. क्यों नहीं होगा? क्योंकि इलेक्ट्रिक फील्ड इधर है, नॉर्मल इधर है, तो एंगल 90 हो गया. नीचे भी वैसे ही होगा, टॉप गया, बॉटम गया, फ्रंट. अब इलेक्ट्रिक फील्ड एक्स डायरेक्शन को फ्रंट साइड अलॉन्ग झड़ आएगा, तो इलेक्ट्रिक फील्ड एक्स है तो ये झड़ डायरेक्शन है, वही भी 90 आएगा. तो हमारा क्या होने वाला है? फ्लक्स ओनली लेफ्ट एंड राइट में जाने वाला है. और इम्पॉर्टेंट है कि ये फील्ड जो है वो नॉन यूनिफॉर्म फील्ड है, क्योंकि एक्स के साथ बदल रही है. यूनिफॉर्म रहता तो ये 0 आता था. तो अब मैं टोटल फ्लक्स निकालता हूँ. total flux is nothing but flux passing through left plus flux passing through right. Then phi total equal to flux. Flux is a product of E and A. Electric field left, area left, plus electric field right, area right. Now, phi total equal to electric field at left E0, x I by B, area each side x, y, z, a, small a, therefore area is a square. E0 x I cap, या I cap को रिमूव कर देंगे, E0 x by B area a square. But x equal to 0 for left side, left face for EFGH, and x equal to a for right face. Therefore, this factor is cancelled. Therefore, total flux is E0 x, instead of x put a, by B a square. Or left flux is inward, therefore also it is negative sign. Therefore, phi total is E0 a x equal to a, area a square. Therefore, total flux is E0 a cube by B. From Gauss's theorem, phi total equal to Q enclosed by epsilon naught. Therefore, Q enclosed equal to phi total into epsilon naught. Right? Therefore, Q enclosed phi total is E0 a cube B by B into epsilon naught. Put the value of each. E0 is 5 into 10 to the power 3, and a equal to 1 centimeter. A cube is 10 to the power minus 6. B equal to 2 centimeter. 2 into minus 2. Epsilon naught equal to 8.85 into minus 12. Therefore, this 2 and 4, 8.85, 4.425. Then 5 into 4.425 into power 3 and 2, 5 minus 18, 10 to the power minus 13. 5 into 4.425 approximate 22 into minus 13. Therefore, answer is 2.2 into minus 12 coulomb. Therefore, charge enclosed by this cubical volume is 2.2 into 10 to the power minus 12. If charges Q1 and Q2 lie inside and outside, Q1 inside में है and Q2 outside में है, closed Gaussian surface, ये closed surface है. E be the electric field at any point on the surface, surface पे electric field है E और flux है phi. तो हमको ऑप्शन में मतलब एक से ज़्यादा आंसर है इसमें. देखेंगे इफ़ Q1 चेंजेस बोथ E एंड phi विल चेंजेस. बराबर है, अगर Q1 चेंज होगा तो phi भी चेंज हो जाएगा. देखो Q1 चेंज होगा तो E भी चेंज होगा, क्योंकि इस चार्ज से कुछ ना कुछ इलेक्ट्रिक फील्ड सरफेस पे रहेगी, और फ्लक्स भी चेंज होगा. ये बराबर है पहला, हमारा पहला करेक्ट. इफ़ Q2 चेंजेस, अब Q2 मतलब बाहर वाला चेंज हो गया, ये चेंज हो गया, तो क्या होगा, E विल चेंज, क्योंकि ये E यहाँ कुछ ना कुछ बदल जाएगा, क्योंकि सरफेस पे इलेक्ट्रिक फील्ड दोनों के कारण होती है, इनसाइड एंड आउटसाइड, एंड फ्लक्स ओनली इनसाइड में होता है, तो E भी चेंज होगा. बराबर है, ये भी हमारा आंसर करेक्ट है. इफ़ Q1 0 एंड Q2 नॉट 0 देन E नॉट 0 बट phi 0. अब अंदर का ही 0 हो जाएगा, तो फ्लक्स का फार्मूला Q इनक्लोज बाई एप्सिलॉन 0. अब ये 0 होगा तो फ्लक्स भी 0 होगा, मतलब ये बराबर है. E नॉट 0, वहाँ पे ही आउटसाइड से आएगा, आउटसाइड चार्ज कुछ ना कुछ अपना ये Q2 यहाँ पे लाइन तैयार करेगा ऐसा, तो इलेक्ट्रिक फील्ड यहाँ से मिलने ही वाला है. इसका मतलब ये भी बराबर है हमारा, तो ये भी करेक्ट आया. लास्ट, इफ़ Q1 नॉट 0, अंदर वाला नॉट 0 है, बाहर वाला 0 है, देन E 0. नहीं, ये गलत है, E तो अंदर से भी मिलता है, ये लाइन पास हो गया इससे, तो इसके कारण ई मिलेगा ना सरफेस पे, कुछ ना कुछ ई होगा। फाई इक्वल टू ई इंटू ए लेते हैं ना हम, तो ई नॉट जीरो रहना चाहिए यहाँ था, हाँ, और फाई नॉट जीरो, लेकिन तीन ही आंसर है, ये आंसर नहीं है। तो याद रखो, फ्लक्स निकालना होगा तो हम इनसाइड चार्ज ही लेते हैं, ठीक है। और इलेक्ट्रिक फील्ड सरफेस पे निकालना है तो सभी चार्ज से ले सकते हैं, इनसाइड और आउटसाइड से इलेक्ट्रिक फील्ड मिलता है, ठीक है। यूनिफॉर्मली चार्ज्ड इनफाइनाइट लॉन्ग वायर हैविंग लीनियर चार्ज डेंसिटी लैम्डा इज प्लेस्ड एट नॉर्मल डिस्टेंस y फ्रॉम अ पॉइंट O. कंसिडर अ स्फीयर O. Consider a sphere of radius r with O as a center, मतलब O पे सेंटर लेना, and r is greater than y, तो y छोटा लेना पड़ेगा हमको, नॉर्मल डिस्टेंस, ये रेडियस है। तो इलेक्ट्रिक फ्लक्स थ्रू द सरफेस ऑफ स्फीयर निकालना है हमको। तो फ्लक्स निकालना है तो सबसे इम्पोर्टेंट क्यू इनक्लोज्ड निकालना ही पड़ेगा। अब देखो, इस वायर का, ये वायर है, इस वायर का लैम्डा कौन है, लीनियर चार्ज डेंसिटी, चार्ज पर यूनिट लेंथ। अब हम कितना स्फीयर के अंदर कितना वायर है, वायर इन स्फीयर कितना है बताओ बरा, ए बी है। तो हम पहले ए बी का लेंथ निकालेंगे। अब ये वाई और आर है तो ये कितना लेंथ हो जाएगा बोलो, ये डायगोनल है तो ये आएगा आर स्क्वायर माइनस वाई स्क्वायर। ऐसा ही तुम इधर की ज्योमेट्री करो, ये ज्योमेट्री करो, देखो ये करो ज्योमेट्री, अंडर रूट में आर स्क्वायर माइनस वाई स्क्वायर। तो लेंथ ए सी और सी बी आर स्क्वायर माइनस वाई स्क्वायर क्यों आया, ये ट्रायंगल देखो, इतना ट्रायंगल देखो यार, हमारा क्या होगा, 90 के सामने का बाजू होगा, और ये तो ये आएगा रिमेनिंग आर स्क्वायर माइनस वाई, ऊपर भी वैसा ही होने वाला है। तो हमें ए सी और ये मिल गया, तो टोटल लेंथ कितना ए बी है, तो ये भी 2 गुना आएगा 2 आर स्क्वायर माइनस वाई स्क्वायर। तो इसके ऊपर चार्ज कितना होगा, लैम्डा इंटू लेंथ 2 आर स्क्वायर माइनस, लैम्डा से क्यू मल्टीप्लाई चार्ज पर यूनिट है। तो फ्लक्स चाहिए था, तो फ्लक्स क्या है, क्यू इनक्लोज लैम्डा 2 लैम्डा आर स्क्वायर माइनस वाई स्क्वायर बाई एप्सिलॉन नॉट। तो आंसर आएगा ये तीसरा। अच्छा, क्लोज्ड सरफेस विच इंटरसेक्ट कंडक्टिंग स्फीयर, a positive charge is placed at the point P, the flux of the electric field through the closed surface। अब देखो यहाँ पे हमें क्या करना है, यह हमारा स्फीयर है, कंडक्टिंग स्फीयर है। अब कुछ बोला नहीं तो ये अनचार्ज्ड कंडक्टिंग स्फीयर प्लस क्यू चार्ज, तो क्या होगा, ये प्लस क्यू चार्ज है, यहाँ कंडक्टर के फ्री इलेक्ट्रॉन इधर आ जाएंगे, इस साइड में आ जाएंगे फ्री इलेक्ट्रॉन, ठीक है, अंदर से आएंगे, मैं बाहर से समझने के लिए दिखा रहा हूँ, फ्री इलेक्ट्रॉन। और डिफिशिएंसी ऑफ फ्री इलेक्ट्रॉन मतलब पॉजिटिव चार्ज जो है वो दूर जाएगा। तो हमें ये इमेजिनरी क्लोज्ड सरफेस से ये दिखाया, इधर देखो ये क्लोज्ड सरफेस दिखा इमेजिनरी, ये तो इसमें से हमको क्या करना है, फ्लक्स निकालना है। तो फ्लक्स के लिए हमारे पास एक ही फार्मूला है, चार्ज इनक्लोज, फ्लक्स के लिए एक ही फार्मूला है, फाई इक्वल टू क्यू इनक्लोज बाई एप्सिलॉन। अब क्यू इनक्लोज कितना होगा, पॉजिटिव होगा क्या नेगेटिव, खाली क्लोज्ड सरफेस के अंदर, बाहर वाला चार्ज नहीं चाहिए, खाली इनसाइड चार्ज चाहिए। तो क्यू इनक्लोज्ड पॉजिटिव है, ये कुछ ना कुछ पॉजिटिव चार्ज आएगा, राइट, कुछ मैग्नीट्यूड होगा उसका कुछ तो, लेकिन हमको मैग्नीट्यूड नहीं निकालना है, पॉजिटिव चार्ज होगा, क्यू इनक्लोज क्या होगा, पॉजिटिव होगा। इसका मतलब द फ्लक्स ऑफ इलेक्ट्रिक फील्ड थ्रू द क्लोज्ड सरफेस, ये भी पॉजिटिव हो जाएगा, विल बिकम पॉजिटिव। मतलब यहाँ से लाइन बाहर निकलेंगे, ये लाइन ऐसे निकलेगी, फ्लक्स परपेंडिकुलर दिखाओ, तो जब भी लाइन बाहर जाते हैं, आउटवर्ड जाते हैं, तो उसको हम पॉजिटिव फ्लक्स बोलते हैं। तो आंसर आएगा विल बिकम पॉजिटिव।